Hello, good morning, good afternoon, everyone. Thank you very much, Nigel. I'm very happy to be part today of this series of webinar, and I'd like to share today some bit of insight about where are we today for some of the applications which are highlighted earlier by Mirela, heavy-duty transportation, where fuel cell has a key role to play. So I'm going to give you a bit of an update of where we are and what does the industry needs to do in order to make sure that fuel cell is a part of the solution to decarbonization and have a carbon neutral economy. So just very quickly, Ballard is a global company with a very strong presence in Europe, and the company is only doing fuel cells. So for the past almost 40 years, Ballard has been developing fuel cell technology. We are technology developer, manufacturer, with, as you can see, a very big focus on heavy-duty application. So today, we power numbers of buses and trucks and trains and ships and forklifts. All those applications have something in common. They need to carry heavy load, and those vehicles have to be on the road a lot. So the demand in terms of duty cycles, the demand in terms of payload, and the demand in terms of routes and range is very important. And this is where fuel cell delivers the best value proposition. So this is where we focus on at Ballard. We manufacture products. We shipped last year roughly around 100 megawatt of fuel cell products to our customers. And but it was important over the years, we have gained a lot of experience, understanding better how fuel cell works, accumulated millions of hours of operating kilometers, as well as proven that fuel cell works. For example, fuel cell buses, which have been in operation in London for 10 years, have accumulated over 30,000 hours of operation without any degradation. We never change the stacks. So it shows that fuel cell works and fuel cell lasts. So what is next? So if you look a little bit at the heavy-duty vehicles, even though heavy-duty vehicles represent much less than the cars, they have a much higher impact on emission. Those vehicles pollute more, and they are on the road much more often. So we strongly believe that fuel cell technology is needed in order to achieve decarbonization of the transportation sector, especially heavy-duty transportation. Fuel cell deliver power, range, payload, so you don't have to compromise on the weight of the payload because you're carrying a very large battery, and having a very fast refueling enable commercial vehicle to operate more, to be more utilized, and that's very important for transit buses and for trucks. So when you look at this very important element of being able to have a long range, to carry a lot of passengers, a lot of goods, and to be able to operate a lot, fuel cell enable the electrification of the transportation sector by making electric vehicle better. And today, keep in mind that most of the fuel cell vehicles are hybrid battery fuel cell. So you get the best of both worlds. So, and if you look at where are the best application for fuel cell, and this graph came out of the Hydrogen Council report and the study which was done by McKinsey, and I will encourage you to download the report, which was published in January. And it really highlighted, on the top right of the slide, which application where hydrogen actually is more competitive compared to conventional option like diesel, and where hydrogen is more competitive to low carbon solution like batteries. And you can see that the one which are the most competitive, the most appealing, are really heavy-duty trucks, medium-duty trucks, forklifts, and buses and coaches. All those vehicles have in common the heavy use as well as the heavy loads they need to transport. So this is where fuel cell can deliver today the best value to customer using hydrogen as a fuel. And what has been interesting lately is we have noticed in the past 12 to 18 months an acceleration of investment and partnership being formed by the automotive sector into the fuel cell industry. You have seen all the major vehicle OEMs or tier one automotive suppliers investing in hydrogen and fuel cell technology. And you see there just a couple of names of companies which have decided to invest significant amount of resources and money into hydrogen and fuel cell. The latest one was the announcement earlier this month of Daimler and Volvo joining together in creating a joint venture to commercialize fuel cell trucks. So we really see, and all those companies have really highlighted that heavy-duty transportation is a big part of their focus. So we start to see now that the industry, that investment is flowing toward the development of fuel cell heavy-duty vehicles. So today, there's probably around 5,000 fuel cell buses and trucks in operation worldwide. There's a couple of pictures here. In Europe, here you can see those vehicles. Most of them actually were part of European funded projects. And you have today fuel cell buses that come on all sizes, all flavor, from 12-meter bus to double-decker or articulated buses. You have also probably around 2,000 of those fuel electric buses in operation worldwide, and around 3,000 fuel cell trucks. A lot of them are those, the one you see here, those 7 to 9 ton delivery trucks operating in streets of cities like Shanghai or Shenzhen. But you start to see in Europe here or in North America, larger truck being developed, heavy-duty trucks for transportation of goods, or even very large trucks like this mining truck project that we are doing with Anglo American in South Africa. So really we can see here the breadth of application, but they have all have something in common. It's all about providing enough power for heavy-duty vehicle for them to perform in their required duty cycles, route, and power requirement. So today, as I said, we have around 5,000 commercial vehicles on the road, buses and trucks. If you had around 15,000 light-duty cars on the road worldwide, so it's probably around 20 plus thousand fuel cell vehicles. Now, a lot of government have, in the past couple of years, including Europe, have published roadmaps where hydrogen is a part of the decarbonization path. So we have seen in the EU, in China, in Japan, in Korea, Australia, and US and Canada have all included hydrogen as a path of decarbonization of the economy. And the goal is to get probably around 10 million fuel cell vehicles by the year 2030 and 2040. So how do we get there? And a number of projects have been announced. At the moment, 350 fuel cell buses are being deployed through the JIVE project, which is funded by the FCH-JU. Some projects like the H2Bus Europe bus program, supported by the CEF funding that Mirela mentioned earlier, is being rolled out now. And you see in different parts of the world, large numbers of buses and trucks are being deployed. So how do we get to 20 million vehicles? I think there are two main things that the industry needs to work. We need to continue to improve and invest in the technology so fuel cell vehicle gets better, and we need to reduce the total cost of ownership. At the end of the day, you can have the best technology, but if it's not affordable for the fleet operators, it's never going to go through. So those two key elements are very important. On the technology side, at Ballard, we keep investing in the technology to make the products better, to make the products more durable, and the products smaller, higher power density, so they can fit easier in the vehicle. They can be lighter, very important for trucks, as they can provide more power, especially as we are moving up with larger vehicles going to trains and ships. You need more power efficient vehicle, and so a lot of investment being done in technology in order to make fuel cell better. But the big challenge is really on the cost reduction. And I referred earlier to the report which was published by the Hydrogen Council. Ballard also published a report with Deloitte at the beginning of the year. So those two reports really look at the cost reduction and scaling up. And what does it take in order for hydrogen and fuel cell technology to be affordable? And those both reports really highlight that within the next 10 years, actually less than 10 years, for commercial vehicle application like heavy-duty vehicles, a fuel cell vehicle will be cheaper to operate and to run than a battery electric vehicle or diesel vehicle. And that's very important. There's really a path today to really do a cost reduction and to make sure, and at the end, having fuel cell vehicle being more cost effective than even diesel vehicle. Now, it's an example here of the trucks. So today, yes, the fuel cell trucks or even the battery trucks are more expensive than a diesel truck. But we believe that there's a path to reduce by 70% the cost of the fuel cell. And just something very important to consider, a fuel cell is an engine. A fuel cell is an industrial part, is made of steel, carbon, aluminium, and is manufactured part, very much like an engine. Today, fuel cell systems are only made by a couple of thousand at a time. But you can imagine if you scale that to 10,000 or hundreds of thousands, not to even say million, the cost reduction potential is tremendous. It's just like an engine. When you look at the complexity today of a Euro 6 diesel engine, it's extremely complex with moving parts, very high temperature, and that engine costs roughly 20,000 euros. So you can imagine taking a much simpler engine, a fuel cell is much simpler, much less moving part, operating at low temperature, using less complex systems, and to be able to drive the cost down of that lower than a diesel engine. Nobody is doing that. So to be able to do that 70% cost reduction, where hydrogen can be at parity as a solution with battery electric and then diesel, which is more important, is feasible. So we need to work on the fuel cell side, but also we need to work on a hydrogen cost. You know, if you look at a TCO vehicle, fuel cost represents 30 to 40%, depending on the application. So to be able to have affordable, low carbon hydrogen is very important, and reduce the price of the fuel cell system. So we believe at Ballard that it's possible. We have a plan in place. We believe that we can reduce the cost of a fuel cell system by 70%. And we are doing that now. We have started that journey. We are not going to do it alone. We are working with industry partners in order to scale up, industrialize fuel cell system and fuel cell vehicle production. We have a number of European customers and European partners helping us to drive down the cost of fuel cell solution. We need to leverage a supply chain, but more important, I think what for me I have seen the most encouraging news is we start to see the automotive supply chain companies like Bosch, Mahle, and very much in Europe or Michelin developing component of the balance of plant of a fuel cell system. So today, as a technology company, we do have access to lower cost, better, more robust components for fuel cell systems, which are being developed by the European supply chain. So that's very important. So to reduce the cost. Now, on the fuel cell side, at Ballard, we have a project which enable us to reduce by 80% the cost of the fuel cell stack by increasing production capacity, by looking at a technology innovation, continue to reduce platinum loading, improving power density, working on new materials for using low-cost carbon plates in order to make the products more affordable, looking at improving production yields. So that program is in place, and we believe that in the next 5 to 6 years, we'll reduce the price of a fuel cell stack by 80%. And more important, we're also looking at recycling and refurbishing a fuel cell. That's a very important element. And fuel cell can be done. Today at Ballard, we are recycling every year several thousand stacks. Customers send us back the stack. We disassemble the stack. We reuse the plate using carbon plates. We can reuse them, we wash them, reuse them, recondition them. The core of the cell, fuel cell, we recycle around 95% of the platinum, which is reused, and then we recondition the stack and send it back to customer. So that's very important in order to reduce the life cycle cost of the product, but also enable the owner to have a residual value on a vehicle. But we are not going to win that battle if we don't get hydrogen also at a lower cost. And this is where, in some part of Europe, in Scotland and others, you can have access to low cost, low carbon hydrogen. It can come from renewable energy, like you have in Scotland with the wind, but some other parts of Europe, including Scotland also, you can use natural gas with the carbon sequestration to generate low carbon hydrogen and low cost. At the end of the day, different studies, either done by McKinsey or done by Bloomberg, have shown that it's possible to reach hydrogen cost at $1 per kilogram. So we have a path not only to reduce the cost of hydrogen, but also we have a path to reduce the cost of fuel cell to make fuel cell vehicle affordable. But at the end of the day, I just want to leave you with one thought. It's very important to have zero emission vehicle, but we need to make sure that the choice of technology we are using is also sustainable, that we don't create any side effect, that we don't have create a lot of waste. And we believe that fuel cell, with being part of the circular economy, will provide not only a zero emission solution, but a sustainable solution. Well, I'd like to thank you very much for your time today. And I hope that I will be able to share some important information with you. And thank you very much for your attention.